We're going to look a little bit into what are called sequences. Sequences are something you've actually seen for your whole life, but maybe not known the notation involved with them. Because all that sequences are a list of numbers in a particular order. You can really think of them as patterns. So when we're talking about sequences, we're talking about patterns of numbers. There are two types of sequences or patterns that we're going to deal with in this class, and they are arithmetic sequences and geometric sequences. Arithmetic sequences are the kind of sequences we had when we either add or subtract numbers from one term to the next to create our sequence. For example, the sequence 5, 10, 15, 20, and on is an arithmetic sequence. If you notice, in between each term, we are just adding 5. That makes it an arithmetic sequence. Now, that plus 5 that I wrote underneath the sequence here is called its common difference. We're going to represent the common difference by the letter D. But what a common difference is the difference or the number that we are either going to add or subtract, so adding or adding negative numbers, which is subtracting, between each pair of terms. If you don't automatically see the common difference, like we could see in this example sequence that it's going up by 5 each time, the way that you can find the common difference is by taking the second number in the sequence and subtracting the first number in the sequence. The second type of sequence that we're going to talk about is called a geometric sequence. A geometric sequence is found when we either multiply or divide numbers to go from one term to the next. You can think about dividing as more of multiplying by a fraction. That's a better way to think about the dividing part of a geometric sequence. So for example, here we have a sequence 5, 10, 20, 40. If we were panicking and trying to see how these numbers changed using addition or subtraction, do you see how they are changing by a different number each time? That means that they are not arithmetic. In fact, we would come back in and notice that this is 5 times 2 to make 10, 10 times 2 to make 20, and 20 times 2 to make 40. Geometric sequences do not have common differences, they have common ratios, represented by the letter R. A common ratio is the ratio, or the number, that we are multiplying by, which is why we're going to multiply some fractions, between each pair of terms. If you could not figure out what the common ratio was in a sequence, you can use the first number in the sequence, that says second number in the sequence, divided by the first number in the sequence to find the common ratio. The common difference and the common ratio for these arithmetic and geometric sequences just tell us how we're going to change from one term in the sequence to another. But we need to be able to use these sequences to create more patterns of numbers. So we're going to do the first couple problems here. It says to first determine if the sequence is arithmetic or geometric, then find the common difference or common ratio. All right, well, let's look at number 1. We always want to start by trying to see what the difference is with adding or subtracting. That's usually easiest. From 1 to 4, we'd have to add 3. From 4 to 16, we'd have to add 12. And from 16 to 64, we'd have to add a lot of numbers. So it's definitely not arithmetic because those are not the same number in the pattern. So we try geometric. To get from 1 to 4 using multiplication, I would have to multiply by 4. 4 to 16, multiply by 4. 16 to 64, multiply by 4. This is a geometric sequence. Since it's a geometric sequence, it's going to have a common ratio, and that common ratio is 4. Since that's the number that I multiplied each term in the sequence to create more terms in the sequence. Let's look at number 2. In number 2, again, if we're trying to figure out if this is arithmetic or geometric, we just need to figure out how the numbers are changing. To get from 3 to 8, we need to add 5. From 8 to 13, add 5. From 13 to 18, add 5. Since all of those numbers are the same, this is an arithmetic sequence. An arithmetic sequence has a common difference since we used addition. And that common difference is a positive 5. See if you can figure out on number 3. Is number 3 an arithmetic or a geometric sequence? Hopefully you notice that if we wanted to use addition, we would be subtracting 20, then subtracting 10, then subtracting 5. And since those numbers are not all the same, we know it is not an arithmetic sequence. But we can try geometric. To go from 40 to 20, I need to multiply it by a half, or divide by 2. From 20 to 10, I need to multiply by a half, and from 10 to 5, I need to multiply by a half. That makes this a geometric sequence that has a ratio of 1/2, because we're dividing by 2 each time, or multiplying by 1/2. Looking at number 4, is this an arithmetic or a geometric sequence? Yeah, hopefully you noticed that these numbers are changing by just subtracting 3 each time. Since I'm using addition or subtraction, this is an arithmetic sequence that has a common difference, and that common difference is -3. Now we just want to be able, again, to use these arithmetic sequences. It's not enough just to be able to tell me what type it is and what type of common difference or ratio it has. We need to be able to do a lot more. For example, on number 5, we have the sequence 5, 20, 80, and 320. If we tried to use addition, we would notice that 5 to 20, that means we add 5. 20 to 80, we'd add 40, 60. And on and on. Those are just not the right numbers. So we try multiplication. To get from 5 to 20, I'm going to multiply by 4. 20 to 80, multiply by 4. 80 to 320, multiply by 4. Great. Since that number is the same the whole time, this is a geometric sequence. So it has a common ratio of 4 because each term is multiplied to create the next term. Now this next part says the initial value. We haven't defined this right now, but we know what the word initial means. Initial means beginning. What is the beginning value in this sequence? 5. That is the first or the beginning value in the sequence. Therefore, we know we can create more terms in the sequence by starting with the initial value and multiplying by 4 every time. So if we continue this, 320 times 4 is 1,280. 1,280 times 4 is 5,120. These are from a calculator, y'all. Then we'd have 20,480, and then 81,920, and on and on. The sequence would continue to grow very quickly because we are multiplying by 4 each time. Let's check out number 6. What type of sequence is number 6? Yeah, even though these are negative numbers, do you notice that we're adding 3 each time? That means that this is an arithmetic sequence. It has a common difference of 3 because we're adding 3 each time. Again, the initial value is the first number in the sequence, and my first number in this sequence is -15. What are the next 4 terms in this sequence? We know it starts with -15 and we're adding 3 each time. So we have -15, -12, -9, -6, and what? -3. What comes next? After 0, what comes next? And after 3? And this pattern continues on and on. That's what the little ... the ellipses here is at the end. It means it keeps going forever and ever. It's a sequence. We're just identifying a few terms of the sequence. We're going to be using sequences in class, and eventually we'll get to the point where we can write an equation to describe a sequence. But first, it's important to understand what we're talking about with these lists of numbers in a particular order, or these patterns of numbers called sequences.